see the book. We have the picture of the book. Do you see the book? Here R means R means the set of all real numbers. C, the set of complex numbers. N, the set of positive integers or natural numbers from 1, 2, 3, and etc. In general, we use notation F, as you see. We use F as a field like R or C, and F power K equals the Cartesian product of F K times. And for a function F from X to Y, we say that X is the domain of F and Y is the codomain of F, and for any set X in A in X and B in Y, we have F of A as F of X for all X in A, and F minus 1 B or inverse of B as a set of X in X when F of X belongs to B. And here I write the F of K as a K tuple like this, when all the x1 to xk belong to F. And you know, for two functions, we can combine G and F like this. They are simple and primary concepts. Definition: a vector space F, a vector space V over field F. So if F is a field, V as a vector space over F, we have two operations. One is addition operation, between two vectors. We denote it by addition sign like this. And another operation is scalar multiplication from the field F cross V to V. For addition operation, it must be abelian or commutative and associated like this, and there must be a unique zero in vector V such that x plus 0 equals x for all x. And other properties for a scalar multiplication, like 1 as a identity of multiplication in field F, 1.x equals x, and the other properties you see. Here the field in analysis is just R or C, not other field. There are many fields in mathematics like Q and other fields, but here when we say F, we mean R or C. Okay, do you hear me? And there is voice and picture for you all. Is there anybody who doesn't see the picture of the book or doesn't hear me? Please write to me if everything is okay. Voice and picture. So there is everything is okay. Okay, thank you. Okay, for in a vector space, for two subspace like A and B, of a vector space V and a member X, and a member X unfortunately internet is not normally normally working. It should wait. You should wait until the problem settles. Okay. The title of the topics, I sent the book to in WhatsApp, and I will send it in audio system too. You can download it. We have about four or five section of the of this book, and I will send you the note of the lectures. After any section, I will send you the note of the section, and the exam will be from that notes. I took some notes and make some PDFs of them. I will send it to you after finishing any section. Okay, for any member X, and subset A and B, we define X plus A, X plus A as a set of X or X plus A for all small a in capital A. And the addition of two subset is defined like this: A plus B equals all the member A plus B for A in A and B in B. Definition: let V be a vector space. A non-empty set in V, like U, is a linear subspace, or briefly a subspace of V if U is itself a vector space. So if U become a vector space, the plus and scalar multiplication, we say that U is a subset or linear subset of V. If you want to know that which condition must be which condition is needed that a subset becomes a subspace. This condition must be held for any scalars alpha and beta in F, and any two members x and y in U. This combination alpha x plus beta y, we call it linear combination of two members x and y, must be in U. So if U has this property, we say that U is a subspace, not just a subset, and we call it subspace test. Subspace test. Okay. Another definition: let V be a vector space, and this V is different from this V. V here means a vector space, but this is just a subset of V. The book shows this as a small v. A subset of v consists of k vector v1 vk as a finite set, and let A be a subset of V as an arbitrary non-empty set. A linear combination of the elements of V is any vector of this form: x equals alpha 1 v1 plus until plus alpha k vk. Here alpha i's are scalar, they are scalars, and v1 until vk are vectors. This combination called linear combination of elements V. V is linearly independent. This is a very important concept in vector space. Vector spaces: linear independent, or simply just independent. If we have the following condition, following implication, in fact. If the following implication holds: if alpha 1 v1 alpha k vk equals 0, we should imply that all the scalars must be 0. If we have this implication, we say that V is linearly independent. V is a finite set, but we can define linearly independent for an arbitrary subset of V, not just finitely. We can define it for even infinite subset of A. A linearly independent A is linearly independent. Here A means the arbitrary subset. A as a subset of V, arbitrary non-empty set. A is linearly independent if every finite subset of A is linearly independent. So for an arbitrary, maybe infinite subset A, we say that A is linearly independent when every finite subset of A, finite subset of A is linearly independent. If A is not linearly independent, we say it is linearly dependent. So independent and dependent, they are two different words. Dependent and independent. Okay. D. The span of A, denoted SPA. SPA is an abbreviation for span of A. SPA. The span of A is the set of all linear combination of all finite subsets of A. So when we say that span of A, the elements of this set is all finite combinations of elements of A. Later we see that a span of any non-empty set is a subspace itself, or a span of A is the we can equivalently say that a span of A is the intersection of the set of all linear subspace of A which contain A. We can say that a span of A equals the intersection of all subspace, for example U, such that A is in U. Okay, this is another way for defining SP of A. So the SP of A, because this is the intersection of all subspace U contains A, is the smallest linear subspace of V such that containing A. So the span of A is the smallest subspace of A such that contain A. Another concept something happened to the internet again. We should wait. Okay. The problem solved. Oh no, it isn't solved yet. Okay, maybe I can continue. So we talked about the span of subset A. Now we say that if V is a E, say E, if V is linearly independent, and the span of V equals the whole vector space, we say that V as a subset of V is a basis. We call V a basis for vector space V. So a subset is a basis if this subset be linearly independent and the span of this subset equals the vector space. If there is a finite basis for V, we can show that all the other bases have the same elements, have the same number of elements. For example, if we have a basis with 10 elements, every other basis must have 10 elements, not more or less. So this unique number is called the dimension of V. So we say that V is said to be k-dimensional or finite dimensional with dimension k-dimensional, if there is a basis of k elements. If there is no such a finite basis, we say that V is infinite dimensional. So any vector space can be finite dimensional or infinite dimensional. If V is a basis for V, then any elements X of V can be written as a linear combination of this form. This is the form that referred the book as a linear combination. So if V equals V1 to Vk is a basis for V. It is linearly independent, and the span of V equals the V. Every element of V, like X, for every element, there are unique scalar alpha 1 to alpha k in field F such that X equals the combination of V1 Vk. Alpha V equals alpha 1 V1 until plus alpha k Vk. This is the finite combination of V1 to Vk. G. The set Fk. Fk means all k tuples of elements of A of F. This is itself a vector space over F. And the basis like this, A1 hat equals 1, 0, 0, 0, E2, 0, 1, 0, and EK, 0, 0, 1. Any index I means the k tuple that at the I space must be 1 and the other must be 0. This is a basis for F. We call this a standard. This basis is a special basis for Fk that is called a standard basis. There are many infinite bases for Fk, but this one is a standard basis. We will sometimes write dimension V equals infinite when V is not finite dimensional or is infinite dimensional. When it is infinite dimensional, we write dim of F equals infinite or infinity. Another definition. For two vector space V and W or a field F, so let V and W be two vector space over F. The Cartesian product V cross W can be a vector space, but with two operation plus and multiplication, scalar multiplication. So if xj vj for j equals 1 and 2 belongs to V cross W, we define x1 y1 plus x2 y2 as a ordered pair, x1 plus x2 and y1 plus y2, and alpha dot x1 y1 equals the ordered pair alpha x1 alpha y1. With this addition and scalar multiplication, V cross W will be a vector space. Another definition. This is in fact an example. It's better to say this is an example for vector space with functions. Let S be a set. S is a set, and V be the whole function f from S, and V be a vector space. Now we define the set of all function f from S to V. S to V by f, S, and V. So for this set we should define plus and scalar multiplication. For all f as a scalar and for all f and all at any function, two function f and g, we define f plus x, g is f plus g, and alpha f in f of S and V by these rules. F plus g of x equals f of x plus g of x, and alpha f of x equals alpha f of x. With these two operations, f will be a vector space over f. A vector space over f. This is in fact an example of a vector space defined by the function from a set S to a vector space V. Again, the problems, we have the problem in the internet. Okay, is there any question until now? You should wait until the problem vanishes. Okay. If you have any question, you can use microphone, or you can write. Okay. Okay, until the problem settled, I ask you about the next week. I suggested in WhatsApp that the next week we have two sessions, two lectures. One at Sunday, uh, 4:30 o'clock Iran times. In Iraq, 4 o'clock. And Tuesday, 4 o'clock Iraq time. And I ask you that if these two times are suitable for you or not. Please write in WhatsApp to me that if these times, Sunday afternoon, 4 o'clock Iraq time, and Tuesday, 4 o'clock Iraq time. If these times are suitable for you, we can have lectures at these times from next week. But one of them, Tuesday, are every other week. I mean 2 weeks, one in 2 weeks. But at Sunday, it is every week. If you agree with these times, please write in WhatsApp. Okay. But the time, if you have another suggestion, the time you suggest must be my free time. Maybe at that time you suggest I have class. And another thing, Dr. Tayyibi asked me to tell you that the lecture time of his lessons are at Wednesday, 1 o'clock Iraq time. In Iran, 1:30. And the next session at Wednesday, 3:30 Iran time, or 3 Iraq time. 2 sessions after the 2 sessions in one day. And he sent me the link of a WhatsApp group. I will send it in WhatsApp to you because most of you have geometry with Dr. Tayyibi too. So you can join the WhatsApp group with Dr. Tayyibi and be in touch with him. Okay. So there are some example 1.6. If S is the set of integers 1 to k, then the set, so S is this set, so the f of S can be identified with f of k. So this is a very important example, but maybe it's not easy for understanding. In fact, f of k equals the all function. You can view f of k as a set of functions. You can view it as k tuples like this, x1 to xk. This is a k tuple, a k tuple. So when we say fk, we mean all k tuples like this. But we can view it as f of s and k, f. For any k tuple, there is a function f such that f of j equals xj. So we can view it as a set of functions. Any k tuple can be viewed as a function. This is very important, especially when S is infinite. Another definition, when V and W be vector space over a field F, a function T from V to W is a linear transformation. Is a linear transformation or just a linear mapping if for any two scalars alpha and beta and any two members x and y, we have T of alpha x plus beta y equals alpha tx plus beta ty. These mappings are very, very important in linear algebra. The set of all linear transformation T from V to W is denoted by L is linear from V to W. If V and W are the same, like this, V equals W, instead of write L of V and V, we abbreviated this to L of V. So when we say L of V, means L of V and V. In the case that V and W are the same. Okay, I think this is enough for now, and next session will be at Sunday, inshallah. Any question? Thank you. So I will send you the link of geometry, and you please join the group and be in touch with Dr. Taribi. And write to me in WhatsApp that if the times I have suggested to you are suitable for you or not. Thank you. Okay, goodbye.